Howdy, my name is Lucky Stokes, founder of Clairvoyance LLC, a deep tech startup, also lead deep learning engineer.
Howdy guys, Lewis Stokes here, working as machine learning engineer,
Hi, my name's Amanda Lugo. I'm the ETL engineer.
and we are Clair.
So our current problem is that current flood maps are too slow and heavy. They take about 3 to 12 hours to process and need about 12 gigabytes of memory per image. Essentially, that uses too much energy, so they can't run on drones or battery-powered devices when first responders need them most.
So our proposed solution is actually a Cascade neural gas. It starts by taking basically the features, which is embedded into our ETL pipeline. It then basically takes a simplex autoencoder, which encodes the actual latents using Numba, a JIT compressed library provided by Python. We then take the hardware efficiency level where we go into Triton and we actually create our own kernel to actually look over and moderate the actual GPU on our devices. And then we offer adaptive learning, which allows us to basically inject multi-resolution prototypes into the actual images to reduce detail loss and noise.
Howdy guys, and so what you see here is our diagram broken down into way simpler terms of the five pipelines that we go through, starting with the raw images of the SAR. We start there, and then we start the encoding process on the 32D simplex along simultaneously with the direct 20 channel encoder. And so that leads to the SWIN V2 encoder, which then goes down into the multi-scale, the unit decoder, the flood extent mask, and then finally into the optional Lohi 2, the high-res feature, and the Gates prototype logits. And so our project scope starting next week will be to finish the Lohi WTA stub and be able to have a unit tested 64 square patch. By the week after that, a full 512 energy probe with energy and a latency chart. By week three, a track one full train with dice and IOU curves. And by the final week, a D-Wave Cubo pilot plus white paper and our final report and code upload to GitHub. And so what you see here is our polarization channel of VV along with our mask.png. And our mask shows where the flood is located at by the square boxes, and the final image shows the overlap of the where the flood is at.
Yeah, so our risk right now is that the ETL pipeline is expanding. And so to mitigate that, we use custom Triton kernels for efficient batching and memory handling. We have a scaling model with dense high-dimensional features. So to fix that, we have merge redundant nodes and multi-resolution expanding, neural gas to balance detail and speed. Another issue is too many prototypes, so we're going to focus on computing only where it is needed.